Have you ever sent a text message to a friend and wondered what happens after you press send? Your message zips away, traveling through the air and across wires, arriving on their screen just a moment later. It feels like magic, a direct and private line just between the two of you. This question is more important than you might think. It's not just about chat messages. Think about all the things you do online. You might buy a new game with your parents, credit card, log into your school's website, or just search for information for a homework project. In each of these moments, you are sending tiny bits of information out into the world. Your name, a password, a search term, or even financial details. This data has to travel from your device across the internet to a server somewhere else in the world. Imagine the internet is a giant network of public roads. Your data is like a postcard being sent from your house to a friend's house. As it travels, it passes through many different hands and many different sorting offices before it reaches its destination. If your postcard was written in plain ink, anyone who handled it along the way could read it. They could see your private message, your address, and everything else you wrote. This is a huge risk, and it was a major challenge for the people who first built the internet. This is the hidden problem of our digital lives. How do we send private information through a completely public space? If your data is just floating out there, what stops a hacker or a snoopy company from grabbing it and using it? They could steal your passwords and log into your accounts. They could intercept private conversations and learn your secrets. This would make the internet an unsafe and untrustworthy place for everyone. The whole system would fall apart if we couldn't trust it. So, the brilliant engineers and computer scientists who designed the modern web had to come up with a solution. They had to invent a way to protect every single piece of data that travels across the network. So if they couldn't protect the road, they realized they had to protect the message itself. They needed to invent a kind of digital envelope that no one could open except for the person it was addressed to. The goal was to make the information completely unreadable to anyone who might intercept it. Even if a hacker managed to snatch your data as it traveled, all they would see is a meaningless jumble of letters and numbers. To do this, they turned to a very old idea, a practice used by ancient generals, spies, and kings for thousands of years to protect their most important secrets. They looked to the world of secret codes. This field is called cryptography, which comes from Greek words meaning hidden writing. It is the art and science of creating and breaking codes. For the internet, they just needed to create a code that was unbreakable. Today, we call this powerful digital version encryption. Encryption is the invisible shield that protects your information every single second you are online. It's the secret code that keeps the entire digital world running safely. So how does this digital secret code actually work? Let's imagine a simple example. Say you want to send the secret message hello to a friend, and you don't want anyone else to read it. You and your friend could agree on a secret rule ahead of time. This rule is called a key. Let's say your key is move every letter forward by 3 places in the alphabet. A becomes D, B becomes E, and so on. Using this key, the letter H in your message becomes K. The letter E becomes H. The 2 L's become O's, and the final O becomes R. Now, if you send the message KHOOR and someone intercepts it, it won't make any sense to them. It's just a random collection of letters. Your secret is safe from prying eyes. But when your friend receives the message, they know the secret key. They know the rule is move forward by 3, so they simply do the opposite. They move every letter back by 3 places. KHOOR turns right back into hello. This is the fundamental idea of all encryption. You use a secret key to scramble information so it looks like nonsense, and then the intended recipient uses the key to unscramble it. Of course, this simple code has a big weakness. A clever enemy could probably figure it out without too much trouble. This is called a substitution cipher, and it's fun for games, but not strong enough to protect important data. A codebreaker could simply try shifting the letters back by 1, then 2, then 3, and so on. Since there are only 26 letters in the alphabet, it would only take them a few minutes to test all the possibilities and reveal your message. The internet needed a lock that was billions upon billions of times stronger. It needed a code so complex and so difficult to crack that even the world's most powerful supercomputers would be stumped. This is where modern encryption gets really clever. Instead of using one shared secret key, most systems today use a pair of keys. This amazing system is called public key cryptography. To understand it, imagine you have a special, magical mailbox. This mailbox is unique. It has a mail slot that anyone in the world can use to drop a letter in. When a friend wants to send you a secret message, they place their letter inside a special box and use your public key to snap it shut. The box is now securely locked. They can then send this locked box to you through the regular mail. Anyone could see the box along the way, but no one can open it. It is completely secure. Here's the truly magical part. Once the box is locked with your public key, that same public key cannot open it. The key only works in one direction, to lock. It's like a padlock that has no keyhole on the outside. The only thing in the entire universe that can open that box is a second, different key. This is your private key. It's a key that you created at the same time as your public key, and you keep it completely secret. You never share your private key with anyone, for any reason. It is yours and yours alone. It's the only key that can unlock boxes that were locked with your public key. This is an incredibly powerful idea. Anyone can use your public key to send you a secret message, but you are the only one with the private key to read it. This solves the problem of having to share a secret key ahead of time. You don't need a secret meeting to exchange codes. You can communicate securely with someone you've never even met before. This exact process happens automatically thousands of times a day without you even noticing. When you go to a website like your bank or a shopping site, you'll see a small padlock icon in your browser's address bar. Your browser then uses that public key to encrypt everything you are about to send. It scrambles your username, your password, and your credit card number into unreadable ciphertext. This scrambled information then travels across the open internet. Even if a hacker is listening in and captures that data, all they will see is a meaningless jumble of code. When the data arrives at the website's server, the server uses its own top-secret private key to instantly unlock the information and read it. Your transaction is successful and, most importantly, completely secure. But what gives these keys their incredible strength? What makes this digital lock so unbreakable? The secret ingredient isn't just clever coding. It comes from the world of pure mathematics. Specifically, it comes from a special category of numbers that you have likely studied in math class. These are the mysterious and powerful prime numbers. As you know, a prime number is a number that can only be divided by 1 and itself, like 2, 3, 5, 7, 11, 13, and so on. They are the fundamental building blocks of all other numbers. Here's the mathematical trick that powers all of modern encryption. It is very, very easy for a computer to take two extremely large prime numbers and multiply them together to get an even bigger number. However, it is unbelievably difficult to do the reverse. If you only have that giant final number, the task of figuring out which two original prime numbers were multiplied to create it is one of the hardest problems in all of mathematics. This is the core of the system. A website's public key is based on that giant, easy-to-create multiplied number. Its secret private key is based on the original two prime numbers, which are kept hidden. Therefore, for a hacker to break the encryption and discover the private key, they would have to solve that nearly impossible math problem. They would have to find the two secret prime numbers, and they simply don't have enough time. Take a moment to let that sink in. The safety of your private messages, the security of online banking, and even the secrets of governments are all protected by a simple but profound mathematical fact. That fact is that multiplication is simple, but finding the original factors is extraordinarily hard. This is what we call a one-way function, easy to do one way, and nearly impossible to do the other. It is one of the most beautiful examples of how a deep and abstract idea from mathematics can become the cornerstone for a technology that shapes our entire world. It shows that engineering and coding are not just about building circuits or writing lines of code. They are about creative problem solving, using powerful ideas from every field of science and math to overcome immense challenges. In this case, the challenge was one of the biggest of our time: how to build a world of trust and privacy on a foundation that is open and shared by billions of people. Encryption was the answer. So the next time you log into a game, send a private message to a family member, or see that little lock icon appear in your browser, you'll know what's really happening. You'll know that in that split second, your device is performing an incredible act of digital cryptography, using a secret code powered by the beautiful and unbreakable logic of gigantic prime numbers. The world is full of invisible codes and hidden mathematics, all working silently to keep you safe.